Welcome to solverfy.
So in question 122, we're given 3 pipes, A, B, and C. We have a cable passing through these 3 pipes. We have a 50-pound weight on one side and a weight of W on the other side. We know the static coefficient of friction is 0.25 and the kinetic coefficient is 0.2. And we're asked for 2 things. We're asked for the smallest weight W that maintains equilibrium, and the largest weight W that can be lifted if B is turned counterclockwise. So let's break this diagram down into our 3 free body diagrams involving the 3 pipes. So we have pipe A, the tension of 50 pounds on one side, and TA on the other side. We have an angle of pi, and we're going to use the static coefficient of friction because the system is in equilibrium. And then we have pipe C with TA going this way, TC going the other way. We have an angle of pi because it's half a turn. And we're going to use the static coefficient of friction again for part A because this system is in equilibrium. And then we have pipe B with the tension TC on the left side and W on the right side, an angle of pi, and we're going to use the static coefficient of friction again because the system is in equilibrium. And we're looking for the case where you have the smallest weight of W, so we're going to take slip in the direction of the 50-pound weight. So we have our 3 equations for impending slip. We have the larger weight 50 over TA to be E to the static coefficient times the angle, which is pi. And so TA is 22.797 pounds. And then we have TA being the larger weight over TC to be E to the static coefficient times the angle. And so TC is 10.39 pounds. And to find W, we have TC being the larger weight, W that's getting lifted up to be equal to E to the static coefficient of friction times the angle pi. And so the smallest weight of W that maintains equilibrium is 4.74 pounds. And that's our answer to part A. So now let's move on to part B. So in part B, we are given the information that B is rotated counterclockwise. So let's make some changes to our free body diagram. So if B is rotated counterclockwise, we're going to use W as the larger weight for pipe B. And we're still going to keep the static coefficient of friction. For pipe C, since the pipe is stationary, but the belt is rotating, we're going to use the kinetic coefficient of friction. And we're going to take TA to be the larger weight because the weight W is getting lifted. And for pipe A, since the weight W is getting lifted by the 50-pound weight, the 50-pound weight is the higher weight. We're going to use the kinetic coefficient of friction because the pipe is stationary while the belt is moving. So let's rewrite our impending slip equations and then calculate W for part B. So for part B, we have 50 being the larger weight over TA to be E to the kinetic coefficient of friction times the angle. So TA is 26.67 pounds. For pipe C, we have TA being the larger weight, since it's pulling the weight W, over TC to be E, again, kinetic coefficient of friction times the angle. So TC is 14.23 pounds. And for the last pipe B, we have W being the larger weight because of the rotation over 14.23 to be equal to E to the static coefficient of friction times pi. So W is 31.2 pounds. And that's our answer to part